Okay, let's look at some application of forces. I want to make it really clear to anybody that's watching this is that I'm teaching it how the exam board would like me to teach. Would like me to teach. So I'm going to just say here, I don't consider this to be my James's teaching, but an exam board specific format of that. So yeah, read into that whatever you will. Okay, so first of all, we're going to have a look at a moving performer. All right, so we've got an athlete here. She appears to be running some kind of marathon. Looks maybe close to the end. Maybe a 10K. Who knows? I think I see the word marathon behind here though. So we've got a moving performer. And obviously, this athlete is covering some distance in a particular unit of time. So what I want to do here is I want to highlight certain factors for you which would be nice. And in fact, I actually meant to put my toolbar on, so let me put that back on here. So the first thing I'd like to do is I'm going to take an arrow, and I'm going to illustrate from the center of mass of this person, and I'm going to illustrate a vector downwards. Okay, now your exam board would like me to tell you that this is the influence of gravity. Okay, when in fact I'd like to tell you it's their weight force, but nevertheless we're going to do it this way. A couple of things for me that are important. Notice it emanates from the center of mass of the performer. Okay, the point in the body where mass is distributed evenly in all directions. So the center of mass of the performer is where that emanates from. And I think it's important to realize that, because if we think about something like weight does not act from one point, it acts for the entire body. So we use this as a representative line to sort of indicate or illustrate that idea. Secondly, we choose another colour. Let's go for something green maybe. I'd like to show you air resistance. Okay, so I'm going to put an air resistance arrow again from the centre of mass, and I'm going to put it something like that. Okay, so now I've got another arrow. You can call it a vector if you wish. And this one represents air resistance. Air resistance. Air resistance. Okay, air resistance. Now, that air resistance there has a certain length. Just as the gravity, or let's call it the weight force, is quite a long force because it's a human body, quite heavy object. Air resistance is not as long because ultimately, although this performer is traveling reasonably quickly, they're not traveling at high speed. Compare it to something like the speed of the initial flight of a shuttlecock or something like that. You know, this is not a very high rate of travel. And what we'll find is that this arrow will become longer the faster something travels. The faster something travels, the more air resistance it's going to have. And there are a couple of other factors that influence, such as what the surface characteristics of the body are, what its cross-sectional frontal area is, for example, but broadly speaking, that's the case. Now, excuse me. Finally, I'd like to illustrate what we're going to refer to as a muscular force. A muscular force. Okay? So we're going to imagine that this foot is just at this moment in contact, and this person is applying a muscular force backwards and downwards in this direction. Okay, backwards and downwards. This is what we call the muscular force, backwards and downwards in this direction. And it's important to realize that from Newton's third law that every action and every force has an equal and opposite reaction. So of course what we're going to find in reality is that this is going to have a reaction force which propels the runner upwards and forwards. In other words, it overcomes it's a response to this muscular force and propels the runner forward, which is ultimately why they're traveling forward, because they're applying force to the ground. So those are some neat little possibilities that you could use there. I'm just going to introduce you to the word vector. A vector is what we're drawing with regard to one of these arrows. You know, we're making one much straighter than these ones. These are vectors. And they have two properties. So they have a direction, because it's an arrow, it's pointing somewhere, and it has magnitude, it has scale, it has size. So the length of the arrow represents how big the force is. So you see here, the gravity force is bigger than the air resistant force. I'm struggling to, yeah. Anyway, so okay, let me not argue with myself there. Let's move on. Okay, now we've got a sprinter on the block here. So what I'd like to kind of do here is I'd like to do the same thing. Let me highlight the gravity force for you, center of mass, acting downwards. There we go. There's our apparently gravity force. There we go. So we've got that gravity. I've highlighted that for you as requested. It's part of our weight force, of course, so is mass. We also want to highlight here what we call ground reaction force. Okay, so I'm going to use a slightly different colour. Let me use a sort of purpley colour here. Ground reaction force. Look, this foot is applying force downwards. So we've got a ground reaction force up there and a ground reaction force up there. Let me get rid of those. So we've got two ground reaction forces. So this is what we call GRF. Let me write it in for you. Ground reaction force. Ground reaction force. So the idea of these forces is, of course, this weight is pushing down towards the ground, and the ground reaction force sort of opposes that weight. And I should have made those two purple arrows together equal the yellow arrow in the opposite direction. And of course, that would suggest that this performer is still, they're not moving. And finally, again, and I've even put in my notes here, because I'm asked to highlight air resistance, and I've put in brackets here without laughing, because what they'd like me to do here is they'd like me to show you the air resistance on this performer. So let's use the same green as I used before. Again, the air resistance would be from the centre of mass back, and look, I'll as I'm requested to, I'll put the air resistance in like that. But can we all agree that in reality, if we think that this person at this very moment is completely stationary, if a performer in the block is stationary, by definition, they have to be still. So at that point, I'd ask you to reflect on how much air resistance there would actually be. So let's assume this guy has just started to move. Let's assume he's just started to accelerate, and therefore we can agree to have a air resistance force on there. Now then, this is an interesting one. What have we got here? We've got a discus. We've got a discus thrower. So I've pictured someone who's about to throw a discus, and we're going to assume that the discus has been thrown and the discus is here. So imagine this discus has got a direction of movement in this direction. That's DOM, by the way. Goodness me. DOM, direction of movement. So the discus is sort of flying off in that direction. So a couple of things to realise first of all. Let me go back onto, let me check what colours I had. So muscular force was blue. So I've got my muscular force, and that has been applied through the centre of mass of the discus, and my muscular force has been applied in that way. So there's my muscular force, so kind of sometimes what we call an action force. Muscular force, that goes like that. The object also has air resistance. Okay, so let's put our air resistance in. So here's our air resistance. It's not going to be a very high air resistance because, again, this object's not travelling particularly fast, reasonably fast, but not extremely fast. So there's our air resistance. And let's also say we're going to put in here, we like to put our gravity force in, don't we? So let's put our gravity force in. So again, not as heavy as a human being. So we've got a gravity force, which is like that. So those are all of the forces acting on that shot at that moment according to your exam board. And again, I'd just repeat for you, there's some terms for you to learn there. I'd repeat for you as well, terms like gravity, air resistance, muscular force, ground reaction force. It'd be good for you to learn these concepts. And yeah, that's, as I said before, that's how I've been requested to teach this concept to you.